All right, let's get started. Welcome to the session on exception handling in functional and reactive programming. My name is Venkat Subramaniam. Thank you so much for joining. Let's talk a little bit about what we're going to do here today, and we'll get going after that. We have about 3 hours, so I'll go for roughly about an hour and 20 minutes. Then we'll take about a 20 minutes break, enough time for you to refill your liquids, use the facilities, and then we'll go for another about hour and 20 minutes after that. So what we're going to talk about is obviously about exception handling, but we'll talk about it from 3 different aspects of it. One from functional programming. We'll talk a little bit about asynchronous and completable futures, and then we'll talk about reactive programming as well, and see how these are handled in all of these 3 different ways of programming. But also we'll talk about some of the consequences of those as well. So we got a fairly good amount of details to dive into as we go through. But a few fundamentals just to set us on the same page before we get going. The first, of course, is to talk about functional programming. I've been excited about functional programming for a while. I've been programming for, I'm going to say, roughly about 35 years now. And for more than, I would say, 60% of that time, I've been programming in imperative style. As a very young programmer, I started programming in imperative style. What I'm telling you in so many words is I had a really troubling and terrible childhood. But eventually, I found the light of functional programming, started programming with it, and got really excited about it. And of course, one of the key things for us to keep in mind is that these are tools. That's what they really are. And if we really get too excited about some tools, we get misguided. We then become fanatic about it, and then we tend to really say, that's the only way to do things. And I'm hoping in this talk today, we'll also draw lines on maybe when it's good to go use a certain way of programming, maybe when it is not a great idea, and maybe consider alternatives as well. So we'll talk about some of those things along the way. Now, in terms of the programming model itself, really quickly, as we all know, in imperative style, we tell what to do and also how to do it. So that is basically what the imperative style of programming is. And in Java, we've been doing imperative style of programming from the beginning. We've been programming with imperative style and object-oriented programming together as a mix. On the other hand, in the declarative style of programming, we tell what to do and, more important, not how to do it. And that is one of the biggest distinctions between imperative style and declarative style. But what I really get excited about functional style is, you could say a functional style is actually a declarative style plus the use of higher order functions. So that's basically what a functional style of programming is. It really brings forward the amazing power of declarative style, and then of course we mix it with higher order functions to build on functions that can receive other functions as arguments, or do a functional decomposition as well. So it's a very powerful model of programming that we are all very used to. Just to entertain the thought a little bit further, one of the key things about functional style of programming is the functional pipeline. So just to emphasize that really well here, let's say we have some numbers as a little example to work with, and we'll start with a list of numbers, let's say 1 to 10 to begin with. And in this case, given these collection of numbers I want to start with, let's say I want to really print out, let's say, the double of all the even numbers, right? A fairly simple example. So you could say a var, for example, a var, I, or a number. In this case, that could come from the numbers collection. This is obviously the imperative style of writing code. And you could say if the number mod 2 is equal to 0, then of course you could output the double of the number. You could say number times 2. So that's the imperative loop that we are writing. But the code is not very cohesive. We all have written code with this for a long time. But that's the imperative style of programming, the nature of imperative style code. But we can also write the code in more of a functional style. So we could simply say numbers.stream, for example, using Java here. And we could say a filter, and given a number, we can say we want to take the number and get the even numbers from this value. And so we could say, hey, give me only the numbers that are even and discard the rest. And we could do a map and say number, and of course, in this case, times 2. And finally, we can do a for each and system.out, and we can do a print line on it, and we could print it out. So this is an example of just looping through and printing the values using the functional style. Now, the reason I get excited about functional style is it's got less accidental complexity. The code becomes easier to understand, easier to maintain. But when you look at this particular code, you often may be wondering, okay, this is nice, and it's nice and cute and expressive, but what about performance? Now, obviously, in this particular case, you are noticing we don't have any extra collection. We simply loop through, and we are producing the output. Maybe we just wanted the first element. In this case, we could even do a break, and it prints out the value 4. But in this particular case, we could similarly do a dot limit and ask for one value from the collection that gives us a 4 as well. But the unfortunate situation here is to understand, what is really going on here? Are we taking a collection and creating one other collection of all the even numbers, and then one more collection of double of the even numbers, only to take the first element and throw everything else? Because if we do that, that'll be rather very inefficient. So from the functional programming point of view, what is really exciting about this is the following, and that is, notice very carefully I chose the word functional style in here. I didn't use the word functional programming. And the reason I want to say that is, I'm going to say functional programming is really 2 parts to it, is equal to, I would say, functional composition that you are seeing right here. And functional composition is really powerful, no doubt about it. But it's plus the use of, in addition to it, a lazy evaluation. So you really want to bring lazy evaluation. Without it, you're dealing with a functional style code, not a functional programming code. So functional composition plus the use of lazy evaluation becomes very necessary. So in this particular case, just to emphasize that point, if I just look at the functional style code alone, and if I were to go back here and simply say that in this particular case, I want to take this code and say, let's say a sample, and we will call isEven as a function, and we'll take the map and say a sample, we'll call it as a doublet as a function. So if I were to write a function right here as a static, in this particular case, let's go ahead and say a Boolean isEven, which takes a number as an argument. And then, of course, I'm going to simply say return, let's say, the number times 2. And likewise, I want to just take this particular function, but I want to call this as integer, and we'll call it as a doublet, and we'll simply return the times 2 in this case of obviously mod 2 is equal to 0 in this particular function. So we can take this particular code and take the numbers collection, and we can iterate over it. We can call the isEven function, call the doublet function, and ask it to produce the output based on what we are trying to do in terms of the collection of data we are working with. So this becomes a functional programming. Why? Because we want to really emphasize the laziness of evaluation in this particular case, because that becomes very necessary. Let's fix the error here. I think I removed the numbers. Let's put that back in. So this is going to be the numbers collection is equal to a list of, let's say, bunch of values we want to work with. Now, this could be a very large collection after all. What if there are 1,000 values that are after this? How are we going to deal with it? Well, the result, of course, is a 4. But what's really cool about this particular code, as we know, is that if you say isEven called for, and you're going to put the number for which it's called, and similarly, if you say the doublet is called for, you can see that it's calling it for only the 1 and 2, and double the value 2, but it never actually touched the values 3, 4, or 5, or 6, or any number of values that may follow this, it's not going to touch it. Well, that is the lazy evaluation that is extremely important for performance reasons and efficiency. So that is definitely part of the functional style of programming. As I was picking up reactive programming, I was struggling to understand what does reactive programming really mean. And of course, I read a lot of material about what reactive means, but I'm a programmer. I want to see things in code, and I want to see how these things actually behave. And I was getting really frustrated, not really figuring out what does it mean. And call me silly, but one day I realized, and I kind of screamed out, saying, oh my gosh, reactive programming is functional programming plus. And the reason I say reactive programming is functional programming plus because it's really built on the foundations of functional programming. So think of reactive programming as a higher level of abstraction starting from functional programming. Now, I mentioned a few minutes ago that functional programming is function composition plus lazy evaluation. So obviously, we cannot imagine doing reactive programming without function composition and without lazy evaluation, isn't it? So if I go back to this particular code, you can see the code right here is a functional style code, as we saw. But let's turn that around a little bit just to consider another alternative. So I'm going to just take one example here. Let's go ahead and import, for example, let's say io.reactive, let's say x.star. So I'm bringing the RxJava in here. So I could say, for example, flowable dot from iterable, and I could provide the numbers collection right there, and we can bring in a flowable into the mix. So once I get the flowable, literally, as you can see here, I'm going to take these two values in here that you see. I'm going to take those two lines and just copy it down below. That's all I did. So I just moved that right in here. And rather than the for each, I'm going to simply say dot subscribe. And in this case, I'm going to simply say system.out and print line. And I'm going to just have it printed right there from the functional pipeline. So you can see that evaluate right there. But I'm going to say take and ask it to get me just one of the values. And you can see the result is pretty much the identical between the two calls. It is lazy evaluation at the very root of it. So you can see the similarity between the two pieces of code. Both are functional pipeline, functional composition. Both are doing lazy evaluation as well. Just the APIs are a little bit different, but the concept is pretty much the same. This is one of the reasons I often say that reactive programming is functional programming plus. But of course, the similarity ends at that point, and we go off in terms of the semantical differences. So it's a good starting point to think about. They both have functional pipeline. They both are using lazy evaluation, but then the abstractions deviate from there as we move on. We'll focus on that a lot more as we go through further into this. But that is one of the concepts that really helps to think about how these things kind of relate to each other. Now, let's talk about exception handling. Well, unfortunately, though, when we write code in languages like Java, we deal with exceptions all the time. And our code is often filled with exceptions in so many places, and we have to deal with not only exceptions, we have to deal with nested levels of exceptions as well. You deal with an exception, and then you try to do something when you have an exception, and if that were to go wrong, what do? And you tend to really have exception handling along that line of code as well. So exception handling is something we do all the time. But when it comes to exceptions, we often wonder, how does this really work? So I want to first of all, start out by saying something we need to really consider in this particular case. So pardon me for a second, just a quick note that I almost forgot to mention. As I'm writing the code here, I will continuously save the code, assuming I remember to do, as I just forgot. But I'm going to eventually put that into my website. So I'll put this URL towards the end of the talk as well. But you can download the code examples from there if you're really interested. It's not there right now, but I'll post it 5 minutes after my talk is over. So you should be able to download it. And I'll post this URL towards the end as well if you want to take a look at it. So on that spirit, I want to go ahead and start pushing this in. So this is a functional and reactive, let's say, programming. And I want to just put a note in here about this as well. So I'm going to say functional style is equal to, a functional, you could say, composition is essentially declarative plus the use of higher order functions, as I mentioned. But I want to say a functional programming is equal to, and I want to emphasize that it is actually functional composition you want to bring in, but you also want to add on to it the lazy evaluation. And then finally, of course, I'm going to say reactive programming is really functional programming plus as I want to claim as a relationship between those two. And that's what we are illustrating in this particular example. So I'll push that into the website after this talk, and you can play with that code if you are interested further down. So we talked about the general nature of it. But when it comes to exception handling, I want to really step back and think about this a little bit further so we can clearly understand what we are getting into. And I'm going to say exception handling is fundamentally an imperative style of programming idea. So it's important to embrace the thought from the get-go, because if we don't, we try to really fight a battle that we tend to often lose if we are really not focused on the overall issues we are dealing with. So essentially, it's important to understand that exception handling is predominantly an imperative style of programming idea. In fact, I'll go even further to say that that functional programming and exception handling, I'm going to say, are mutually exclusive. So they are mutually exclusive, and it's very difficult actually to mix functional programming exclusive, and it's very difficult to really match functional programming with exception handling in general. So exception handling is an imperative style of programming idea, and functional style of programming is predominantly a functional pipeline, lazy evaluation, a flow of data through the pipeline. And exception handling is fundamentally opposed to that kind of model. It will not work very well with this at all. So I titled this talk as Exception Handling in Functional and Reactive Programming. And I just mentioned functional programming and exception handling are mutually exclusive. I hope you found this talk useful. Thanks for coming. Well, of course, right? So knowing that it has limitations are extremely important for us to keep that in mind, because if we try to fit something that doesn't fit, we're not going to get the best results. And we feel disappointed, we feel confused, we feel the code is getting convoluted. But if we step back and ask the question why, it becomes a lot easier to think about it. But this is also even more important to reason with. And I'm not exaggerating this. This is actually a true story. I got an email from somebody who said, hey, Venkat, the Stream API in the JDK does not support checked exceptions. So I forked the JDK and modified the entire Stream API to handle checked exception. Would you please do a code review for me? And I replied to the person saying, I'll be happy to do the code review, but I want you to just answer one question before I do. And that is, if you can fork it and change it, I think the people who wrote the JDK are as capable, if not more, to do the same thing. Can you tell me why they didn't do? Then we can talk about how to actually do it. Well, that is the problem, isn't it? Because we tend to really jump on solutions sometimes, but it's important to really understand the problem before we jump onto the solutions. Otherwise, we feel disappointed with the solutions we seek, and the problem is still left intact, strong, without being solved if we try to solve problems without understanding it. So that is one of the things I want to really focus on today, is to really think about some of these concerns as well. So exceptions and functional are mutually exclusive. Keep that in mind. We'll come back to this a little bit later. But let's start with a little bit of imperative style of code in Java to begin with and see how we can proceed with this. So let's take a little example and play with it as one step at a time. So let's start with a little example code. As you can see, after lunch, I write code really fast. So right there is a little function I call as get name of airport, as you can see. I'm going to lower the font a little bit so you can see the code a little bit better on the screen right here. So this is basically a function that says, well, go out to a URL, find out the IATA code for a airport. Given that code, find me the name of the airport. Again, it's a code where I'm a little lazy to really implement the full code, so I'm just going to grab the name of an airport and return it upon the call. Let's just start with a little example and play with it. So I'm going to call the get name of airport, and then I'm going to provide IAH here, for example, which is the airport in Houston, and I want to be able to get to the details of that. So I'm going to bring in a scanner here that is needed for this. So I'll just simply say a star on that one, and maybe a net as well. So let's just go ahead and bring those in and try it. So in this case, I have an IO exception as well, sure. So let's go ahead and provide that and see how that goes. So this says exception must be caught or must be handled. Well, as experienced Java programmers, we know exactly how to take care of that. So we'll just go ahead and say throws exception for now. We'll come back and talk about that a little bit more. So run the code, and you can see it says George Bush Intercontinental Houston. So that code seems to have done its job in getting the airport name given the airport. Well, okay, well, I don't promise that will work for all the airports, but it seems to work for a few at least. So right there is a little piece of code we wrote. But when you look at this code, this is typical of a lot of code we write where we call a get name of airport, and you can see it takes a code for an airport. Potentially, it may throw an IO exception, and then we go off to a URL. We access the content from that URL. We are taking the content out of it, and then stripping out some data we want, and we are returning that, and in the process, it gave us the name of the airport. So that's good so far. Now let's say we want to work with a collection of airports right now rather than just one airport. So we have an IATA codes, a bunch of airports in Texas. And what I want to do is to be able to print out the names of each of these airports. And I'll come back to that in just a minute. So how do we go about using that information? You could say for, and in this particular case, let's go ahead and say for IATA code, we'll say, and that comes from the IATA codes, obviously. And then for each of the code given to us, I'm going to simply print out, let's say, the name of the airport. Very simple case, right? So I'm going to say get name of airport and say IATA code and simply print it. So if I go back and run the code for each of these airports, you can see there's Austin and there's Houston, there's Dallas and San Antonio. So you can see the values come through pretty nicely, not a problem. However, going back to this particular code, what if I remove the throws exception right there for a second? Obviously, the code is not going to compile. I need to handle the exception. Well, it's a good time for us to put this over here and say, I want to do a catch and maybe an exception in this case. And all I will do is simply print out the exception get message maybe. I'll convey what happened right there. So that's basically the code I'm going to write for that piece of code. The compiler was happy with us, gave us the result we are expecting as well. But what if I make a mistake here and I say TAS and I don't think there's an airport with that name in there? That's another thing from my life story is we are a family where we travel a lot, and that's when when the entire family can communicate using airport codes, that becomes very disturbing. But we seem to know these airport codes quite often in terms of where we are. So running this code, obviously you can see it gives us the Houston and Houston and Austin and Houston and Dallas. And then in the end, it gave San Antonio. But right in the middle, it says invalid airport code TAS. And it prints that particular message. And that's because, obviously, we got that from here when the request was successful, but there was no such airport. Obviously, you could have a network failure rather than a failure of the response. So if the network had a communication problem, even for a valid airport, you may get a network error. In that case, it's going to display that you have a network error for that. It's going to deal with it. However, looking at this a bit more carefully, we have a collection of airports. Now, in this case, we were looping through one at a time. When there was a failure for an airport, we reported the failure gracefully and moved on to other airports. Well, if you were to write a program, you cannot tell your users, look, I'm really cool, I'm writing code in functional style, but it won't work the same way as you expected it. That's not going to cut it. So the users don't care whether the code is imperative style or functional style. The users care that the code produces the results they expect it to produce. So if I were to take this code from imperative style and write it in functional style, I have to preserve the behavior of the code. I cannot give you a different output and say, this is good enough. I got to really make it consistent after all. So the question is, how do I really be able to get to that particular point of consistency in the code? Well, we'll come to that in just a minute. Let's go ahead and save it as an imperative style code, and we'll just save it away. So that's basically the code we just wrote, and we are dealing with an exception as well, and I think we did it fairly well. And if you really ask me, what is one strength of imperative style of programming? I would say it is dealing with the exceptions, because we are used to doing this quite often. We write code and we deal with an exception, and then of course we can deal with multiple nested levels of exception as well. So this is something we are really good at doing when it comes to imperative style of programming. We have been doing this for a long time. We can handle that. Now, on the other hand, though, what if we want to take this code and we want to convert this code into a functional style? Well, before we go, I do want to say, let's step back a little bit and think about the history. Some of you probably have been programming long enough that you remember the history. Some of you are probably relatively young. Maybe you were born with exception handling around you in the way that it's done, and you probably don't realize the pain that the old folks like me had to go through back in time. So if you think about the way back in time, we wrote functions which were performing some calculations or computations. They returned the data. And then we said, gosh, what about errors? I know this is a bit naive, but once upon a time we said, positive values are data, negative values are errors, as if values cannot be negative in general. That worked a little bit until we realized that results can be negative as well. Oh, darn it, that doesn't work really well. Let's try it again. Then we said, well, here's an idea. A function returns a 0 if everything is good, and returns an error code if something is wrong. You say, that seems like an interesting idea. So you got an error code as a response. But what about the data? How do you get it? Oh, you can send a pointer or a reference to a function, and the function can fill it in and return the value. Now, obviously, this complicated the API when we had to make a function call, and that was not a very pleasant way to write the code. Nevertheless, even more, people could ignore the returned error code, and the program could be misbehaving, and we didn't have a really good way to handle it. So we struggled with that for a while, and then we said, well, here's another idea. What if we were to maybe call a function, and the function is running just fine, then there's no details of error to deal with. But if anything were to go wrong, we'll blow up the call stack and throw an exception. And unfortunately, that idea took a lot of popularity over time, and we started running with it. My biggest complaint is that we should have never called it exception handling. We should have called it normal handling. Because if we called it normal handling, maybe we'll think about it differently. Now we call it exception handling, and we look very surprised when it happens. And that is not a really good way of programming. In fact, this reminds me of one experience which is unfortunate in my mind. But I was speaking in a conference not too long ago, and one of the persons in the conference came to me and said, hey, Venkat, you probably don't remember, but I took your distributed object computing course back in 1998. I said, oh my gosh, I remember teaching that course back in 98. Well, it's great to see a student from the past. And he said, but I got a story to tell you. And I said, I love stories. Tell me what story you have. And he said, well, I was in your distributed object computing course, and we had a project demo where we have to demo the project we built the entire semester. And we were doing the final demo when you walked up to my machine. And remember, this is 98, right? We had these things called Ethernet cables. And so he said, you walked up to my machine and you disconnected my internet connection and said continue, and my program crashed wildly and I failed the course. And I said, that's a tragedy. Why do you want to tell the story to me right now? I feel terrible that you failed the course. And he said, no, there's actually a happy ending. I said, how could there be a happy ending after you failed the course? I am really curious to know about it. And he said, well, that's the last day I ever programmed the happy path. So nowadays, when I sit on my computer, I just don't think of the happy path first. I actually think through the code a lot more, deeper, thanks to you. And he went on to say, in my office now on the cubicle, I have a picture of an evil Venkat. And I look at the picture every day before I code, and I never get this problem again. I don't want to know how this picture of evil Venkat looks like, but the point is that we need to really handle exceptions as well. Otherwise, it's really going to be a problem for us in the code, so we cannot just focus on happy path. Well, exceptions, unfortunately, tend to really make us think about this as, oh my God, shouldn't happen. But exceptions can be normal. It could be a sequence of operations that could happen. So now that leaves us again thinking, how do we handle normal errors versus exceptional things that are showstoppers, and there's no real good way. So the short thing I would say is, as a field, I don't think we have an answer yet. So it's very important to keep in mind that exception handling is not the way to solve the problem. You could ask me, how do you then solve the problem? I don't have a clue. But I think it's important to at least recognize that we don't have a good solution yet. And I think we should continue as an industry, as a field, to explore other ideas to maybe make this better one day. But we cannot really become complacent and say, we figured this out. No, we haven't. So we really need to take the time to understand how to handle errors and the flow of code. That's still quite messy in what we do. But let's think about handling this in a functional style code. How do we really approach it? So as you can see in this particular case, the code executes and produces the result. We got the airport names for valid airports. We got an invalid airport when it is not. And then the code continued to produce more results. That's really awesome. Well, that's good so far. But let's go a little further with this. Now what I want to do is to say, I have an IATA codes right there, and I'm going to say .stream to get the stream of the data in the functional style. So that's good so far. Then we can say a for each, and we'll say system.out and do a print line on it. So we can say, I want to print out the data for each of those, and you can see the code being printed. That's great. But then what I want to do here is to say a map function. In this case, I'm going to say, hey, I really want the names of the airport. Let's actually make this a little bit verbose just to handle this. So I got a code, an IATA code. And given the IATA code, I want to take this code that's given to me, and I want to do some work with it. So what do I want to do? You can see the code is happy with me so far, but I'm going to say get name of airport and say IATA code right there. So this is very beautiful. It's elegant. It's concise. It's something you want to keep looking at, but it doesn't work. And that's the sad part of this code, isn't it? Well, what is the problem with this code? The compiler is not too happy with us, and it gives us an error, unreported exception. IO exception must be caught or declared to be thrown. That's what it says. So you're thinking, what do I do with this exception? Well, I'm sure almost every one of us have tried this at one point, right? You said, no worries, I can take care of it. And you put a little try block around it, and then you put a catch exception, and you say, I want to simply print out the exception. Talking about design patterns, this one has a pattern as well. It's called an act of desperation. So you can try that as well, right? It's like, I'm going to handle the exception right away, and you could try something like this. But unfortunately, though, the reason I say act of desperation is after all that effort, you compile the code, and the compiler says the same damn thing again, right? It's completely merciless, isn't it? The compiler doesn't at least say, I know, you tried something, my dear programmer, but explain to me. It's like, no, I'm going to say the same thing again, right? How cruel it is, right? It's as if you never did anything, just gives you back the response and says, deal with it. And you're sitting and scratching your head the first time you ran into it, maybe you're thinking, what's happening here? So we'll just save it as an act of desperation. And that did not really help us. So let's try this one more time. Let's undo that change and say, what should I do right now in order to handle it? Now, at this point is called a realization point, because this is a great time for developers to stop and say, maybe I should think about this a little bit more. But some programmers are absolutely eager to write code. They don't want to stop thinking. So what do? They say, aha, I know exactly how to fix this problem. And they go out here and they say, the problem is the checked exception here, isn't it? So what they do immediately is, and I'm kind of writing a little bit of an easier code to explain here, they could say a string get name of airport to, which takes an IATA code, right? And then, of course, they say return get name of airport with the IATA code. But then they say, I want to call that function, isn't it? So I'm going to call the IATA code 2 right now. But then within this function, I'm going to go ahead and take this exception that's given here, catch exception, obviously that's given. And we're going to then say throw new runtime exception, right? And exception EX. Have you ever seen anybody do this before? Yeah, we all have, right? But never want to admit in public who did this, right? So we do this. Now you kind of wonder, what is this called? This also has a name for a pattern, and I often do this. This is called curl up in a corner and cry pattern. Because when you look at this code, you're like, darn it, what did we do? Because when you run this code right now, what does it do? It blows up with a runtime exception, and that's what you get, right? A big call stack on your face, not a very fun experience. So I will just simply say, don't do this, obviously, right? Just to make it very clear, right? Not a good idea, right? So don't do this. So this is not a great idea, and we have seen people do this oftentimes. What did they do? They are saying, oh, compiler, you don't want to let me have a checked exception. I will show you how to deal with the unchecked exception. That doesn't solve the problem, actually. In fact, the compiler was trying to help us. And we just said, shut up. And the compiler's like, OK, I hope you know what you're doing. And it doesn't really complain after that. So not really a great idea. So this is an anti-pattern rather than being a pattern in general. So we should definitely not go this route. So this is, avoid rolling into a runtime exception. This is not a good idea. So let's save that away. So what actually went wrong in this particular case? Now, obviously, when you look at it, you had to write another function in this particular example, and that particular function had to catch the exception and blow up with a runtime exception. But people are relentless. When you write bad code, it's important to stop writing bad code. But sometimes people take that bad code and they generalize it. And now they want to have a way to repeat bad code over and over without much effort at all. So this is where it gets even more dangerous, where they say, hey, here's a great idea. Let me create my own function to convert exceptions to runtime. This is anti-pattern gone terribly wrong, right? So then they have a nice library of function that will convert all functions to runtime exceptions. And this is when all hope is gone, right? It's dark and it's going to be really gloomy. There's no way to recover from this. But you can try this as well. You could write a more generalized function to do it if you want to take that up a little further, and this is even more terrible. So for example, rather than introducing that separate function, we could say, for example, here is a function we are returning and convert to runtime exception, and you can try to take a function on hand. And what are we going to do in here? Well, obviously, a function EX. What in the world is a function EX? So we create for ourselves an interface right now, which is our own interface, which can handle exceptions. So you could say interface function EX, which takes a type T, and an exception E extends maybe an exception. And of course, in this case, we could say that's our functional interface we just cooked up. And this functional interface contains a public and, let's say, a result that it's going to return in this case. So pardon me, this is going to be a result R. So we'll just use an exception inside of this. And that's going to be an apply function. And what does that do? Takes an input, but it throws an exception in this case. So when it throws an exception in this case, how are we going to use that particular function? Well, the good news right now is we can now call the to, but not in the map. But so we can then go back here and say, this is going to be convert to a runtime exception, and we can provide into it the data that we want to provide. So that's going to be the IATA code. So pardon me. So let's go back to this one here, and it's going to be that function we're going to call the convert to IATA code, and then we can take the code right there, and then we can call that particular function in there, and that's going to say, hey, I will return to you a function that the map will be happy to receive. So the problem in this case is, if you look at the definition of map takes a function, but a function's apply method doesn't throw any exception, checked exception. As a result, the compiler doesn't allow us to deal with it. So taking the bad idea and extracting into a reusable function, sometimes you see people go overboard with it. And you can say in this particular case, what do? You want to return, obviously, a function in this call. So you could say, I want a function that takes a data. So you could say input. And what are we going to do with that input? You can then say in here, this is going to become the function you want to call. So you can put a try block around it and a catch exception, let's say EX. And this is going to simply say a throw new runtime exception. And then, of course, in this case, you can throw that away. And this becomes a return, a func.apply, and take the input and return it from there. Now, again, before I go further, don't do this. So I always try to put these in talks these days, because otherwise somebody takes a photo, puts on Twitter, and they say this guy's an idiot, right? So it's always better to say don't do this, right? This is not a good idea. So it's better not to encourage that kind of programming, though you probably have seen people really go overboard with it and try to extract that in some case. So it's giving us a compilation error, but I won't bother fixing it, right? So don't go this route, not a good idea. So more anti-pattern, not a good idea. So what should I do if that is the case in this particular case? Well, the problem really is when this blows up, what's going to happen? The answer is, if there is an exception in the functional pipeline, it blows up the pipeline. So that's one of the problems, is it's going to blow up the pipeline. So what that means is, one, we have a messy call stack to deal with. That's the first problem. Second problem is we lost the ability to process, so the ability to process the values that follow in the collection. That's another problem. And a third problem is, don't even ask, how does parallel work, right? So that is like, oops, it's already messed up, and now we want to know how does it work in a parallel situation. So the problem seems to get deeper and deeper and deeper as we go through this. Not a very pleasant experience to deal with, as you can see in this particular case. So again, that's basically, again, I'm sure you've probably seen people do this as well, is to put a curly brace around it and try to handle the exception right there. This is even more worst syntax where we are trying to really put a little code and put a try and catch around it and more mess, right? So more mess, not a good idea. So once again, you want to really avoid such code. So it's really no good solution going this route. So we definitely want to avoid it. So what's the solution? As we saw in parallel, it gets even worse. So this is where I think often about what does life become when we do these things? And as a way to express my feeling, I think I tweeted this last October, and my tweet basically is this. For this Halloween, I have chosen a costume of exception within functional style code, right? So this is a nice way to scare everybody around us. And you're like, oh my gosh, how do I really handle this exception in this code? The code becomes a mess to deal with, not a very pleasant experience in general. So definitely avoid that. That's not a way you want to go. So what gives? What do we do? So let's step back a little bit and think about this again. And I mentioned that exception handling is imperative style of programming idea, and in functional programming and exception handling do not go well with each other. So then the question is, what do we do? How to handle this? So the answer to that question is, I'm a big fan of giving analogies. When I talk about programming, I want to talk about analogies from real life. And I want to say, oh, this is as if whatever. I never ever thought I would use a programming metaphor in the real life. This is nature in reverse. So this was right before the pandemic hit us. This was January of 2020. And I spoke, this was January, I spoke in the Boston, New England Java user group, amazing user group, had a great time. And it was maybe about 9 p.m., maybe 9:30 p.m. And I said to myself, maybe it's time to drag myself back to the hotel. And I had a flight to Montreal to speak in a conference over there the next morning. And I said to myself, Montreal from Boston, yes, it's a neighboring country, but it's international flight, but it's not that far of an international country. I'm a traveler, I can handle it. I don't need to worry about this, I told myself. So I checked into my hotel about 11 p.m. My flight was at 6:30 in the morning. So I said, I'll get up at about 3:30, leave about 4 o'clock. That's plenty of time to go to the airport. So this was about 4 a.m. I step into my car, start driving, and it had snowed that night, and so the entire road was filled with snow. And you can imagine the entire road is empty, and this is about 4:15 in the morning, in the night, and I'm driving when I hear a little thump, and the next thing you know, my car doesn't want to go as easily as it did. So I stopped my car in the middle of the road, got out and looked at it. My front right tire was busted. And I'm like, uh-oh, I've got a flat tire. What do I do? And I look around, there's nobody around. So I immediately called the renting company and wanted to say, I got a flat tire, I need help. My flight is in nearly 2 hours and 15 minutes. And I called them, and their automated service was amazing. They said, your call is important to us, which means nobody cares about you. And so they said, your call is important to us. We'll be with you in about 2.5 hours. I'm like, no, that's not going to cut it. I'm going to miss my flight, and I'm going to talk right as soon as I land over there. It's important to take this flight. So sitting in the middle of the road, not knowing what to do, not having anybody to call at that time of the night, and honestly, I'm not exaggerating, I thought about exception handling and functional programming. And I said to myself, what do you do in functional style of programming? And the short answer in functional style of programming is very simple. Treat error as data and deal with it downstream. And I repeated this a few more times in my ears. And that gave me a new courage. And I said yes. And I turned up the ignition, put my foot onto the pedal, and drove all the way to the airport. And you should have seen the people at the airport because they heard loud noise rolling in. The people working in the rental car company. And one person stopped everything and came back and said, "Are you okay?" I said, "Oh, I'm just fine. Just the car tire is flat, but that's okay. Here's the key." And I just bolted off to take the flight. And took the flight, went there, gave the talk. Amazing, no problem. About a month went by, and my wife called me. I was in Europe at the time, and she called me from home and said, "Hey, remember you said this experience in Boston?" "Yes, I remember that." And she said, "Well, you just got the bill from the car rental company." I said, "Let me sit down. Let me know what the deal is." And she said, "Oh, they charge you $65. I'm like, "I can handle that." So the moral of the story for you from now on is, if you have a flat tire, don't stop, right? No, just kidding. Don't take driving advices from me. But the point is that's exactly what I did. I just drove to the airport and of course, dropped the car off and took the flight. But this is really, motivation was, how do you deal with it? The answer is, deal with it downstream. So essentially, the first idea is treat error as data and deal with it downstream. So you want to treat error as data. So what does that really mean, to treat error as data? That's the first thought we need to see, that we have a data, but we want to be able to treat error as a form of data, and then, of course, deal with that downstream. So remember, say that you have a good friend of yours, and your friend calls you in desperation and says, "Hey, I'm driving on the middle of the freeway. I have a flat tire. What should I do?" The worst thing you can ever say, especially if you don't want this person as a friend anymore, is you can say, "Blow up and drive in reverse," right? You don't drive in reverse on a freeway just because of a flat tire. But that's what an imperative style of programmer probably would do, right? "Hey, I've got a flat tire, I'm going to start driving in reverse." The cop catches and says, "What are you doing? Driving in reverse?" "Well, I'm handling my exception," right? No, you don't blow up your call stack and keep going back to the call stack. That doesn't work. So what would you tell your friend? You would say, "Hey, first of all, safety is important. Pull over to the shoulder and exit safely." That's a good recommendation. So in other words, you always keep the flow moving forward. You don't have the luxury of going in reverse in the call stack. So essentially, you have a functional pipeline, but you want to keep going forward in the functional pipeline. So deal with it downstream and keep going forward. That is extremely important for us to do. So let's come back to this in a few minutes. So how to deal is the question. So we'll come back and look at this in a few minutes and how we can do it. So how do functional programming languages, or languages that tout a much better functional style at least, deal with this in general? We could think about the Haskell way. How do Haskell programmers deal with exceptions? Well, the cool thing about Haskell is you will think about Haskell and say, "This is going really well," until they use the word monad, and now you have no clue what's happening, right? Well, basically, this becomes a monadic style. Well, they'd call it a maybe monad. "Oh, well, there's data, but when things were going wrong, maybe we'll give you a maybe and you can deal with it." But essentially, the idea behind this is you really want to capture the errors and you want to move it forward. That's what you're really trying to do. And how do we really deal with it? Let's take a look in this case using a little example from Scala, and then we'll relate this back to Java and see how we can do this in Java after that. So let's go over to a little example here and give it a try. So let's go over to this particular function we have right in there, which is the get name of airport. So let's start with that function that we have right now. So let's grab this one. So I'm going to just convert this code over just for a minute. So let's go over to, let's say over here, we'll do a sample.scala right here. And then we will go ahead and see how we can do this in Scala. So here's the function. So what am I going to do? Simply say that this is a function called get name of airport. That's going to take a IATA code, which is a string, obviously. We want to take a string. And just as a quick note, Java is the only language I know on the JVM which really cares about checked exception. All the other languages simply say, we don't care, so they all treat exceptions the same. It's a compiler feature than a JVM feature, so Scala doesn't care about checked exceptions. So in this case, I'm going to simply say, here is a URL I'm going to bring in, and this URL obviously is going to be the data that I want to bring in to this particular field that I want to bring in. Actually, I'll keep it very simple here, IATA code. Let's go over here to the scanner. I can just keep that the same as it is right now. We'll just simply use a val instead of a var for these. And then, of course, I get a response from this particular call. And once I get the response from it, I want to see if it contains the name. If it contains the name, that's great. Otherwise, I want to throw exception right now. Otherwise, I'll simply come here and we'll return the value, which is the split of that value from the call itself. So let's go ahead and put a little parentheses for the indexing over there, and that's going to be the value we're going to return. So that becomes my little function I want to call and return the response from it. And I don't need the try block, obviously. If the exception were to happen, we can simply blow it up from this call and move forward. So that becomes the nice little code to respond with the call. And again, I'm not going to handle much at all. Let's see if that actually works. So I'm going to call the get name of airport, and we'll try this again like we did before, and see if it reports the airport name. In this case, it's giving me an error on the scanner because I didn't import it. Let's go ahead and see import right here. And this is going to be java.util.star. We'll just bring that in right here as well so that we can use those two in here. So a syntax error again on line number 7. Let's see what error did I make on line 7. This is going to be an open URL. Yes, an extra parentheses. Let's get rid of that. So that's basically the code. We're getting there. So essentially, line number 18 is unhappy with me. So print line, and I'm going to print out the get airport name right there from the get airport, and that's going to report the value. This is going to be the end of it. Anyone sees the error? So in this case, we are looking at, let's see what the error says in here. So it says syntax error on line number 18. It's not happy with my print line. We'll get to that in just a second. So that's my IATA code. I want to return back that particular response. So, OK, so no main. So that's good so far. So this is going to be a call to print line. And I want to print line this particular value, get airport name, and that's going to be IAH, let's say, and I want to print it. And maybe that's what it's complaining about, that it couldn't find the main. OK, so awesome. So with that code, how do you really handle exceptions in this particular case? Well, Scala doesn't have checked exceptions, right? Everything is unchecked exception, so to say, and you just need to deal with them when they happen. But the question is, how do we really make this work properly in the case of an exception? What are we going to do? How do we really deal with exceptions properly? So the answer to that question is, you can do a few different things in Scala to make this work properly. I'm going to skip that part. So you can ask it to execute the code with a little bit of handling in here. So you could use what is called a try, and a try is a very interesting object. So think of a try as a union more than anything else, if you will. So if you think of it as a union, so a try may potentially have a success or a failure. So it can carry a data, or it can have an error that it can carry through between those two. So what you could potentially do in this case is you're saying, look, I'm calling this particular function, and it could potentially blow up, may have an exception that it's going to throw. So how am I going to handle that particular exception? Again, remember the treat error as a form of data. So what are we going to do with it? So what you can do is you can say, I want to write yet another function right here. So let's say the function I want to write here is try to get airport name, and I simply roll it up into a try object like so, get name of airport and IATA code. And you can ask it to bubble up that particular value as a try. Now, what this basically does is it can return a try with data which case it will be a success, or it returns a try with a failure, in which case it says there is an error, I want to capture this error and move it forward. Well, so that seems like an interesting idea to begin with, but where does this take us? Well, when you are trying to deal with the code, you may do something along these lines. For example, let's say you have a collection of airport codes. You could say IATA codes is equal to, let's say, a list. And in this case, I want to say, let's say this is going to be AUS, let's say IAH, and maybe a TAS, which is not valid. And then you could say, SAT. Well, in this case, you could say, I have an IATA codes, but once the codes are given, you could do a map on it. And in this case, you could simply say, given a code, I want to call the try to get airport, and then you can pass the code to it. So what this is going to do is, it's going to return a try object as a response to this call to the map. And when it returns a try object, what you wanted to do in the past was the following, right? You wanted to take this one, and you had to map, and you wanted to, let's say you want to take this name and convert to uppercase, and you print it. Well, you could say the name of the airport, and you could have said name.to uppercase like so. But you cannot do that anymore. The reason is you're not dealing with the name, you're dealing with the try that potentially wraps the name into it. So what you're going to end up doing right now is something along these lines. So you're going to say in here, I want to take this name given to me into this particular object, and I want to say that if that object contains a value, transform it. If it doesn't have the value, simply move the error forward. So this simply is taking the exception, or the error rather, which is of type exception, and moving it down the pipeline, or if it's a data, performs transformation. Well, that's a good step right now, but what's the next step after this? We want to then take the data and print it out, maybe potentially, or print the error if there was an error, but that's going to become a little bit more messy on the next call, as you can see in here. So what you're going to then do is the following. You're going to say at this point, I'm going to take the data excuse me, and match it. If it's a success, I want to get the name of the airport. If it's a failure, I want to get the message out of it. So then you can get the value, and finally, of course, you can print it out at that particular point. So that could be an approach that you can take in a language like Scala to do this. So a lot of programmers were excited and influenced about this particular approach. And the question is, how can we do something like this, if you will, in the case of Java? So let's take those ideas, the spirit of that, and see how we can apply that in here with the Java. So we want to treat error as data, right? That's what we are trying to do, and we want to be able to treat error as data and push it down the pipeline. So let's explore this idea. So let's say we want to have an interface we want to create, and we'll call it as a try interface, which is going to deal with some type T that you want to really work with. So in this case, the type T, and I can say in this, I can have a class called success, and the success basically can say it implements the try type, as you can see here, that you can bring in from the base. Similarly, you could also come up with a class called failure, which implements, let's say in this case, the try as well. You can bring that in. So now, of course, you want the functions to be able to provide you a try when a failure were to happen. Let's take an incremental step towards this and see. Of course, you could use third-party libraries, for example, like Waiver, and you can do some of these things a little bit more easily, but I really want to focus on the core syntax to think about how this is actually going to happen. So you can take the IATA codes right now, and you can say in this case, I want to really perform a map operation where I take an IATA code, but I want to then come back with a try as a response. So in this case, you can say try you could say get airport name, which is the function we have right here, get name of airport rather. So I want to be able to try get name of airport, let's call that function. And in this case, the result of that is going to be a try that you're going to get back from that particular call. So we can say here is the IATA code I want to send to that particular function. So we'll start with that first, and then we'll expand on that as we move on. So what am I going to do with the function? So public, let's say in this case, here is a static, let's say a try, and this is going to be try of what? Well, that's going to be a string after all, because you're going to get the airport name if everything was going well. And here's a try get airport name, which takes IATA code as a data. So now, of course, we want to go call our function we are interested in running. Now, before we go further, let's take a quick detour on this. Sometimes we use things and we may not really pay attention to things, but in the java.util.concurrent, you remember seeing a function interface called callable T. And on the other hand, you have a java.util.function package, and you have a supplier which has a T in it. So if you remember the callable, that contains a function called call, and you have a function in supplier which is called get. So you kind of look at these two and say, why would we have a supplier when we had a callable already, right? So, I mean, sometimes we do this, right? We have a code, but we also, it's my code, I write this, right? But clearly, I don't expect that from the JDK team, right? So there's got to be a good reason why they have these two. Well, as it turns out, the callables call has a throws exception attached to it. So when you deal with the functional pipeline, you cannot deal with an exception. So the supplier is much like a callable, except that it doesn't have any exceptions, it throws. That's kind of the reason why they went this route to have a supplier. So for all practical purposes, they are fairly similar to each other in terms of what they do. They both return to you an object, maybe with a connotation that a supplier may potentially create an object and return to you, but in a sense, they both are giving you an object. That's what it really is. So something to think about along those lines. But how do we really make this work? So we clearly want to call this function called getNameOfAirport, which is going to return the data to us. So we could try something along these lines, and we could say, for example, return, we could say try dot, and we could create an object from this one. So you could say try, and you could pass maybe the IATA code, and you can get an object from it. So you could do something along the lines of, maybe in this case, you can say, get name of airport, and you can provide the IATA code for the airport and ask it to provide that. So what is the try function? Try could be a static method in the try that is going to return the object to you. And without trying to get too concise on that, I'll simply say try for now, and that can be refactored out later on if we desire to. So this can return a try object for us, and which is a try string in this case we are expecting. So we could build up on that, right? And we can say, hey, my try object is going to simply have a function called a try. So you could say a static, in this case, we could say a public, let's say a static try, and this is going to take some kind of a function to work with. And this is going to be maybe a supplier or a callable potentially. We could say a callable of T, and this could be a function, we could say callable. So that's going to return a data back to us on the call. And so then what we can do is with that, we could say something along the lines of, let's say concurrent star, because that's where it's sitting. And we could say, I want to return an object on that particular call. So what are we going to return? So we can simply say, in this case, we want to return a success, right? That's what we want to create, a new success. And what are we going to return for the success? That's going to be a success of whatever the result of the callable.call is, and we can wrap this up into the call and return it. So this gives an idea of how we could potentially write a try function to elevate this into a success, but these basically are derived classes from here, so as a result, a try may potentially return a success, or if there's a failure, it may potentially return an error as well. So this code becomes a lot more simpler as a result. We can simply say return try.try and just pass the function to it. Now, obvious question is what's going to happen if there is a failure, right? So we can say here is a try block, and we can then say, I want to handle an exception if it were to happen. And so in this case, we can say catch, and here is an exception I want to receive. And what am I going to do in this case? I could say return a new failure of t. And in this case, we could simply say exception. We could just take the exception and roll it in and pass it around as a failure object. So potentially, we could return those two, which means the success needs to take data as a constructor argument. So we could say here is a success, and the success is going to be containing the object t. We'll say value, and we could simply save it away, right? This dot value equal to value, and store it away. And that's the value we are interested in. Well, if it's an exception, obviously you want to store the exception, and you want to bubble it up to the caller after that. So that's a first step you could take. Well, okay, so that seems like, I don't know, whether you use a third-party library or whether you hand toss it, you probably just eliminated some boilerplate code you would have written otherwise, but you are getting there at this particular point. Now, what about the failure in this case? You could again say in this case a failure, and this could potentially take a exception that you are interested in dealing with, right? So you can store this exception right here, and you could say this dot, maybe in this case exception, is equal to exception. You can store that away. If you want to carry it forward, you could say here is the exception I want to carry it, right? We'll come back and refine this a little bit later. So that could be an exception you are propagating through from this particular call. So seems like we could either get a failure or a success. Then what do we do? Well, obviously, we need a way to perform the next level of mapping. So this is going to give us a try object, which is a success or a failure. Well, what's the next step? Maybe I want to convert the name to uppercase. So you can then say, I want to take this, and this becomes a try object. And what are you going to do with the try object? You could do a try.map, and you can then say in the map, if it's a data, maybe you want to take this data and say data.to uppercase, right? So you could convert this to a uppercase if it's a data. So what would a map function do? Think of a map much like a map in optional. So if you think of a map in optional, the map in optional says, I will let you transform a data if it exists, otherwise simply return an optional empty moving forward. This is very similar to this. Instead of sending the optional empty, it's going to send the failure over. So the map is going to transform a success from a success to another success, but it's going to take the failure and just move it over. But of course, there's a type conversion when it comes to the failure as well. From one type to another, that becomes necessary as well. So you can then transform the data through that. Well, great, we got the data transformed. Then what's going to happen after this step? Well, the next step after this is you could say, I want to take the data and maybe I want to print it. But when I want to print it, I want to know if it is an error or if it's a data. Well, if the types are the same, you luck out a little bit. If the types are not the same, you may have to convert it even further. So this becomes a try, obviously, try, let's say, that may be a syntax error, but just look at it conceptually for now. And you could say, if there is an error, you want to get the data. Otherwise, you want to get the error from it. And so that may be a transformation. So this step, you could say try dot, and you could ask the question, right? Is it an error? So if, error, you want to perform one transformation. If it is not an error, you want to perform another transformation. Once you do that, what's the next step? You can do a for each, and you can take the data and you can print the data out. Again, like I said, if the data is not the same type, you may have to do one more transformation to get the string or representation and print it out. Let's say we go this route and make this work. What's going to be the consequence of this particular approach? Well, first of all, this code will work, right? So you're going to look at this code and say, yeah, that works. Well, will it give you the data and the error and then the data? the chances are, yep, that's going to work as well, because you're going to transform this into an object which carries the error, and you're going to take the error and move it forward. So as a result, if it's a data, it goes through a transformation. If it's an error, it, in this case, is going to just move it forward to the end where you're going to handle it. So the good news is you're dealing with it in the end of the pipeline. What is the disadvantage of this particular code? The first and foremost, I would say, it doesn't matter what language you're using to do this, I would say the code is no longer cohesive. So this is, to me, one of the biggest challenges with this particular approach. The code is no longer cohesive. So what I mean by that is, at every level, every step of the way, you are asking the question, is it data or is it error? Is it data or is it error? And you're going back and forth with this, and you are trying to determine what to do with the data, and if it's an error, what do you do with it? So your code is not as clean as it once was, right? So the functional pipeline is no longer as clean as it was before. So that is another disadvantage you are running into in this particular case as well. And to me, the essence of, right, so in a sense, when you look at it, you can say that with this kind of nature of code, I would argue the simplicity, the clarity, the ease, and various other benefits I would normally say, are much lower with this than when we deal with pure functions that do not throw any exceptions. So that's another point to really think about it. So the question we want to ask is, does exceptions make the code impure, right? And from the fundamental point of view of functional programming, we want to really focus on purity of function and transformation. This seems to really bring a level of impurity to it. The second question you want to ask is, how do we deal with multiple levels of exceptions? So you deal with an exception, and when you get an exception, you want to do something else with it. Well, that layer in the pipeline is going to become even more complicated when you are dealing with the multiple levels of exception, and the code no longer is going to be as simple as it once was. So the code, the benefits of functional style begins to diminish at this particular point. And if you then take a look at this code and you want to maintain it, you're looking at this and saying, wow, is this code really as maintainable as it was before when we dealt with functional style of programming? So one of the questions you want to ask is there a range in which maybe functional style is a suitable solution, and maybe there's a range when functional style is no longer the most suitable solution? And I would say, to me, when my code doesn't deal with exceptions, I love functional style of programming. But when I have to start dealing with multiple levels of exception, and the code becomes really spread out with multiple levels of exception handling, I tend to really back out of functional style in general. I am much more comfortable writing the code in imperative style. I'm not in a competition. I don't have to prove to anybody that the code has to be in functional style. Remember, the code has to be maintainable. That's our goal. And to be able to release a product that is easier to maintain in the long run. So I don't think we should shy away from the imperative style all the way through. And in general, I would say, try these ideas, but don't force yourselves to stick to it to say, I've got to write this code in functional style. If the code is easier to understand, if the code is easier to maintain, I would say go with it. But the minute the code is no longer easy to maintain, the code begins to smell, the code becomes less cohesive, much more difficult to maintain, then trying to compel ourselves to using functional style may actually work against us in this case. This is one of the reasons I emphasize the word, we're not in a competition. It's very important not to get into a mode where we have to defend against a particular type of solution or speak in favor of it. These are just tools, and I generally tend to really use the tools where it may make sense. And if a tool is not the most appropriate in a certain situation, I think it's more pragmatic to pick the right tool for the job than to stick with the wrong tool, even though that may not be the most effective in a given situation. So this is basically, if you're doing purely a stream-based solution with functional programming, I would say that's my general recommendation is you probably don't want to continue with this kind of approach when you are dealing with a stream API. Be mindful of why exceptions are not really handled by the stream API. They were not naive about this. They were thinking through this quite a bit, and there's a reason why they didn't really introduce a solution, not because they can't really add a solution that others have added. It is because, in my opinion, it's not the right solution. And I think it's really prudent and wise of the JDK team, in my opinion, is that they shied away from providing a solution which may not be the most appropriate solution because it doesn't really favor the functional style of code. Now, so that is basically in terms of how the functional API is. I'll clean up this code and push it into the repository so you can look at it, but with the caveats I mentioned are really important to keep in mind when it comes to this style of programming. So where do we go from here? Like I said, it's rather unpleasant, and you don't want to really do this unless you have clarity in the code. So if you are going this path and things are getting really treacherous, don't hesitate to fall back into imperative style, because I think that's much better and manageable at that particular point. Well, when we come back from the break, we're going to talk about two more things. We'll talk about how completable futures deal with it, and then we'll talk about the Reactive Stream API and how they deal with it as well. So we're ready for about 20 minutes break, and I'll see you right after that. Thank you. All right, hope you had a good break. Let's talk a little bit about exception handling and how that translates to a few other different programming models. Well, first of all, JavaScript has a concept of promises, and Java has completable future. And it turns out the ideas of completable future are very similar to the ideas of promises in JavaScript. So the question is, how does that model work, and how are exceptions handled in that particular model? That's what I want to focus on for a little bit in this part. So let's talk about promises, or you could say, our completable future. So essentially, the idea is, if you're dealing with a asynchronous piece of code, so you want to write a non-blocking code, you want to make a call, you want that to go off and do things, and when the processing is done, you want to perform the next stage in your computation, and you want to be able to do that. Well, that's a very powerful programming model, but the question is, how does this actually work, and how do we deal with the data and the exceptions in this particular model? The name here is a railway, like a railway track model. So think about this as a railway track. So you have a railway track, as you would imagine. And in this case of a railway track, let's say you have a top-level track and you also have a bottom-level track. So you have these two tracks that you have in here. So essentially, you are looking at stages of computation. So when you're in the stages of computation, so you could first of all, for example, take a piece of data that you can work with, and you can call a function with that piece of data. Now, the function could perform some operation, and what it's going to do is to return a promise or a completable future. So think of a promise or a completable future as an object that would yield a result back to you. So you could have three different states, if you will, of the completable future or a promise. So the states are, really one of, you could be in a pending state. So if you're in a pending state, you haven't finished it, you haven't resolved it, and it can be in a pending state for a long time, waiting for something to happen for it to resolve or reject. And the two other things are resolved state and a rejected state. And you can say these two are really terminal states in this case. So once a promise gets to a resolved or reject state, it doesn't change, but from a pending state, it could potentially change. So those are really the stages of computation in which a particular completable future might be at any given time. So you could be in a pending state, and then once the computation is over, it becomes resolved. If something were to fail, it becomes rejected. So far, so good. But how does this really take us forward? Well, the beauty of this is you can be in a nice pipeline. So you could be taking a completable future and call a function as a next stage. And that may take you to the next completable future, and you can have this pipeline of processing that you can go through in this particular sequence of computations you want to perform. So once again, you see the evidence of this functional style, functional composition that you're going to be looking at. But the semantics are quite different in this compared to what you saw before. One of the biggest differences is when it comes to a stream, you may have a 0, 1, or any number of data. On the other hand, when you look at a completable future, may have 0 or 1 piece of data. So this is a single pipeline, single use pipeline. So in other words, you're going to be going through this pipeline once from the top to the finish, and that's basically execution of the pipeline to transform the data. So you're not really streaming data through this. It's one data transformation that goes through in a completable future in a sense. So, but in that case, how does this really deal with data, and how does it deal with error? Let's say you are in a function like this one, and it says, hey, this is great. I was able to perform the computation. It resolved, and I have a good response, a good data. Well, if it's going to resolve and get a good data, you could say you are on the top path. You can call this the happy path, if you will. So you are going to go from one function to the next function, and you're going to have this happy path that it produces right here. So maybe this was resolved, and you have a data right there. So you could say that this is a data that you're going to carry forward. So this data now, because this completable future was resolved, goes to the next function. The function says, hey, I'll take the data you give me, and I'm going to move it forward to the next phase. And in this case, it becomes the transformation of the data again to the next phase. So you could be hopping from one to the next, to the next, to the next, and you could be on the top level quite a bit moving forward because everything was successful so far. So that looks pretty exciting in terms of carrying through with the data. Let's take a look at this really quickly before we go any further with this. And in this case, I'll simply show how we can deal with the exceptions. I'll come back to this example a little later on, but let's just entertain this thought for a second. So let's say we have a completable future is equal to, we'll say create, and I'm going to call a function called create, which is going to return to me a completable future. So I'll go ahead and bring in a concurrent star, which is where the completable future is sitting. So we'll say public, let's say static completable future. Let's say in this case is going to be create. And what does this do? It simply says, let's keep it very simple right now. Return completable future, let's say, dot supply async. And I'm going to simply return a little value, let's say, from a function called compute. So the function, let's say, in this case, compute, is going to simply, let's say, return, let's say, a value of 2, right? Very simple it may take a little longer to run, but I'm going to return that particular value. So if I were to go back to this code just to illustrate this point, and I'm going to say print the details of the completable future, notice it says not completed. Well, that's a pending state as you would expect. That's what it tells us, right? The completable future has not completed yet. That's what it tells us. And as they say, time cures, so let's put a little time here. Let's put a thread dot sleep for just about a little, don't need that much time, but let's just give a little delay in here just for seeing the output of this. And then after that, we'll ask the completable future what it wants to tell us. And in this particular case, you can see it went from not completed to completed normally. That's what you're seeing here. So we saw, basically, in this case, we saw the pending state, we saw the resolved state as well. It was not done, and it's completed. That's what we are seeing right here. So that's the completable future we are creating. But what I can then do is, I can say in here is my completable future, but I'm going to say a dot then apply, and I can take the data, and I can do a transformation of the data times, let's say, 10, and I'm going to transform the data. So this is where you are in one stage of the pipeline, you go to the next stage of the pipeline when it was successful. So you went from this stage here to this stage saying, yep, everything was great, I want to move forward. So in this case, you can then say a dot then accept, and you can take the data and you can simply print out the data at that particular step, and that's your display of the data. So you're taking the value of 2 that you have in here. So then apply. Let's make sure I got this right. So I want to take the data from the completable future that's given here, and I want to apply that particular transformation, and then accept the data, and I want to print out the data eventually, right? That's what you're trying to do. So essentially, in this case, you are transforming the data. And then you are saying, once the data transformation is done, I want to simply display the data at the result in the end. So what is this completable future type is? This is, of course, Java. So you better say this is an integer type that I'm dealing with, and you are trying to multiply the 10 with that value, and you are displaying the result of 20. So you take the 2, multiply with the 20, and you print the result with the 10. The result is a 20, and that's the result you are seeing right here. So this is the happy path that you are journeying through as you go through in this case. So what is nice about this? You are able to focus on just the data, as you can see in here. You can then go a little further with this, and you can say, maybe I want to do a +1 of the data, and you can see a 21 being printed. So this is simply saying you are then taking the data that you got here, and you're going to the next function, which is next resolving, and you can keep moving forward. That's your happy path. But what if something were to go wrong? What do? Well, if something were to go wrong, your function is going to now return an error rather than success, right? So let's say going back to this, let's say this was a failure, it returns an error. So this is going to be an error that you're going to propagate at this point. When an error happens, you come down to the unhappy path. So think of this like a railway track, and you're just moving forward, but you can be bouncing back and forth, right? You're on the happy path, unhappy path, happy path, unhappy path, and you can keep going back and forth as you move forward. So now you are in the error right here, and it says, look, that failed. I'm sorry, but we met with the failure. What do you want to do? Well, you can take this failure, and you can send it to the next function. The next function can take the failure and say, I'm sorry, this is beyond any reasonable repair. I can't do anything with it. It can propagate yet another error moving forward. So that is one option. Or a function may take the error and say, hey, I can recover from this, in which case you can bounce back to the happy path and keep moving forward. So in a sense, you can build up the stages so that you can go from a success to a success, or success to an error to a success, and back and forth, and you can keep moving forward like that. So the way to think about this is, Here's a way to look at it. Let's say you have a promise or a completable future, as we talked about, and that is in a resolved state, let's say, in this case, or it is in a rejected state. So it could be in one of those two stages. If it's neither one of them, your pipeline is not running, right? It's pending. But the minute a pipeline stage resolves or rejects, it's ready to go to the next stage moving forward. So you are here. Now you're in a function, let's say, your function is receiving that particular completable future. What does it do? It says, I'm going to fix it. I'm going to resolve it, or I'm going to cause a failure because I couldn't handle it, right? So that's going to be just a failure to be reported. So what's going to happen at this particular point? Now, in this case, what's going to happen is, what is next? What's going to happen is, go to the next then. So if you're in resolve, you are into a function. If the function was able to recover from, give you a positive result, you go to the next then. Well, you are in a reject, and the function says, I'm going to mend it. Guess what's going to happen? Go to the next then. So in any stage, you're going to get to the next then when there is a data that you are able to process. On the other hand, when you are in the resolved state and you run into a failure, you say, oops, we got a problem. What do we do? Well, go to the next. I'm going to use the word catch for now. We'll come back and refine that a little bit later. Similarly, you are already in the rejected state. You ran into a problem. What do? Go to the next catch. So in other words, in every single step, you make a decision. I am here. If it's a success, I go to the next then. If it's a failure, I go to the next catch. So essentially, you keep moving forward and you decide where you want to go. So what is this catch that we are talking about here? Well, the developers behind the completable future had a weird sense of humor. They decided to call it not as a catch, but they called it exceptionally. So exceptionally block is part of the code is called whenever you run into some difficulty. So essentially, you know what exceptionally is. It's when something goes wrong, you want to handle it, right? That's what exceptionally is. So let's take a look at how this is going to work in here. So this is a simple example, as you can see, but I'm going to go back here and say something like a public, let's say, static int transform, and that's going to take a number, let's say, and in this case, I'm going to say return a number, let's say, times 10, and that's what we're going to use. Now, obviously, when you come in here, we will simply say transform called, so you know that this call was executed, so we can see the behavior of this code. And what am I going to say here? It's a times 10, so I'm going to simply say here comes a sample, and I will call the transform function right in there to call this. You can see transform called, and it said 21, so that part is good. However, let's go back to this code and say something along the lines of if, let's say math.random is greater than 0.5. Let's say in this case, throw new runtime exception, and we will send a message. Let's give something which we often see in production, right? Something went wrong, right? So that's very useful message. So we're going to just blow up with a message, something went wrong, and provide that. So in this particular case, I'm going to simply say, a transform, let's say failed, right? That's what I'm going to say. In this case, the transform failed. Now, as you can see, when I run the code this time, it says transform called, transform failed, and run this again a few times. Now notice in here, when the transform is successful, you can see the value is 21. But if the transform is not successful, what happened? Well, remember what this code is going to do. When a failure happens, it goes to the nearest catch or nearest exceptionally, but there is none, so it didn't do anything. So how do we deal with this? Let's go back to this code for a second, and in the very end of this, I'm going to say dot exceptionally. And this says throwable, and I'm going to say handle exception and provide the throwable to it right now. So this is basically saying, I want to provide an exceptionally block and provide a throwable and call a handle exception. Let's give it a try. So what does the handle exception do? So I'm going to say in here, handle exception takes a throwable, let's say throwable, and that's a throwable that I'm going to receive right there. And within this, I'm going to simply say, let's start with baby steps right now. So what am I going to return from this? Let's say I'm going to return a type T right now, and I'm going to simply return a null for now. Let's come back and refine that a bit later. And in this case, I'm going to say output will say, handle exception. And of course, I'm going to provide the throwable so I can display that particular information. So we'll say handling exception and the throwable. So we provide that particular call right there in the sequence. Now notice what it displays as an output. It says transform called, transform failed, and it says the completion exception, runtime exception, something went wrong. That's what it tells us. So it's printing the information about the exception right there and tells us something went wrong. So if you again look at this one, the transformation failed and it reports something went wrong. But if I run it again, notice there's no message. It simply says 21. In fact, let me just put this as a .get message right here to see if it's a little less noisy in there. So that's about when it's successful, that's when it's failure. It says handling exception and it says something went wrong. So what's going on here? Well, you can see that the failure happens in this code right there. If there's no failure, what did it do? The transform succeeded, returning 2 times 10 is 20. It went to the 20 plus 1 is 21, and it printed the 21. That's a success path when everything worked really well. That's what you saw in here as an output, as you can see, with the value of 21 that's going to be printed. If it is successful, that is. It doesn't want to go into that route, but you get the point, right? So that's basically when it's successful, it's going to print that result. But if it were to fail, on the other hand, what does it do? It notices that you have an exception in transform, and so when the exception is in transform, what does it do? That's resolved facing a problem, so it goes to the nearest exceptionally. So at this point in code, it skips this and ends up directly right here into the exceptionally block, right? Now we just want to do the other one. So right there, you can execute it. So right there, it's the output. As you can see, something went wrong. So essentially, the idea behind this is it goes to the nearest exceptionally block, as you can see. Now, how do we structure the code with this? Now, like I said, this is a weird name for a function, but it's not not that unuseful to have a method like that, because you could always know one thing, right? Because you know what exceptionally means right now. It really means you are dealing with a mess that happened up in the pipeline. So when the boss comes to you and asks you, how are things going? You can simply say exceptionally, right? So you know what that means, and everybody around you who are programmers know that as well. So it's an exceptional code at this point, absolutely. But you can now see where you can handle this pipeline. You can take this exceptionally, and you can move it up here if you really wanted to. And now you are saying, I want to receive this block of code right there as a handle exception. And in this particular case, maybe I want to transform the data and send something down the lane if the failure were to happen. It's really up to you as to what you want to do in such a situation. And you can say, look, if there was a failure, I want to propagate that failure as a data to process down the stream. You could potentially do that as well in this particular case. So this gives you a bit of a handle on how you want to process that information as well. So in this particular case, for example, let's say if you run into a problem like so, if I were to say this is an integer that I want to return from here into this handle exception, I could potentially say I want to return 100 maybe if this was to handle it and return a data from there. So in this case, what's going to happen right now? So this is going to, if there was no exception, The 20 comes to here as a 21, and it prints 21. If there was an exception, you're going to go to the exceptionally, right? If there was no exception, you bypass exceptionally, right? This is the happy path. You go from then to the next to then. You're not going to go to the exceptionally. So in this case, if it was a success, you're going to go straight through to 21, which I hope I'll get sometime when I try this, and you will see the value 21. There you go. So the transform completed, the result was 21. The moral of the story is you bypass the exceptionally. However, if the failure were to happen, you went into the exceptionally, it printed something went wrong, gave a value of 100 instead, and then we took the 100 and added 1 to it, and the result of that, as you can see here, is 101 as a response. So essentially, this is the railway track pattern where you can provide these exceptionally blocks at various points in time for you to transform the data. So now obviously the question is, what's going to happen if there was a failure in this area of code? Well, then it's going to go to the nearest exceptionally from there. So in other words, if the failure were to happen in another stage, you'll go to the next exceptionally, and then you move forward. That's basically the way this is organized. So what's the good news and what's the bad news? The good news, in my opinion here, is that a bit of a clarity for these functions. And I have to say, I really like that part. So the part I like about this way of writing code is that then focuses on the data that you want to work with. The then is not struggling with data versus error. Hey, I'm in the then, I focus on the data, that's all I care about, right? I don't have to worry about the error, that's not my concern. What does the exceptionally say? The exceptionally says, I worry only about the error, I don't have to worry about the data. So it's a nice separation of concern. The code is a little bit more cohesive. So definitely better than we trying to do the try and success and failure in the code as we tried to do before. You don't want to get into that kind of mess in this particular case. So this is a lot better. Unfortunately, though, this is not perfect. The reason this is not perfect is, so let's take this a little further, and try this out. Let's say we have a data that we have, and then we will also say in this case, we want to perform a value for the transformation. So we'll say, multiplier, and we'll bring in the multiplier in here, and we will provide the multiplier. So just to entertain this thought, if we go back here and say, here is the data that we are receiving, and we call transform and pass the data and a 10 to pass in, so that's going to transform the data and return that's great. However, if I come back here and say, here is a transform, but that's going to multiply with the 2, let's say. Now what's going to happen in this particular code? You can see the transform failed, something went wrong, transform was called, and transform failed again. So there's 2 failures that you see. But why is there 2 failures? The reason is this one failed, so the exceptionally kicked in, it returned 100, and this one again failed, and when this failed, what happens? It tries to go to the nearest exceptionally, but there is none. So as a result, there was nothing to report the failure. So in other words, you hop over the exceptionally if it's success, you hop over the then if it's a failure. But this can be in multiple levels. That's the part that makes the code a little harder as well, because when you look at the pipeline is now interleaved with all this code that could come in like so. So in this particular example, what's happening? You can see that it failed. You come into the something went wrong. That succeeded. So you bypass this exceptionally and you got here. On the other hand, if you come in here, the first one failed, well, same as before. When you run it again, the first failed, and let's see, the second one were to fail again. It's going to be, there we go. So the first failed, the second failed, but you reported 100. Why is this? Because when this failed, you go here, it returns 100. When that failed, you go here to the exceptionally, which returned 100, which you printed here. So essentially, you are interleaving these exceptionally and then, and you, in your mind, you have to separate these 2 pipelines that are interleaved in here. And at every stage of the pipeline, you get to decide, do you want to go up and deal with the happy path, or do you want to go down and deal with the error? And you get to decide whether you want to come back up or stay in the bottom, and you're going to go back and forth through this. So that is basically your pattern here, which is the railway track pattern that you see that you're propagating through. So on one hand, what I really like about this approach is that you can have a nice little code that is separated and cohesive at each level. But the point I don't like about this as much is the interleaving of these exceptions. So I'm going to just save this here and save it into the file so you can take a look at it when I post it later on. So that's the part I don't really like as much is the fact that it actually interleaves and can make the code a little harder to follow and harder to understand as well. So again, not a perfect solution, if you will, in terms of what it can provide. And you have to really deal with this back and forth. We'll come back and talk about the other example in just a minute and see how we can implement this using that solution. But we'll say completable future, and exceptions. So essentially, that's the path you're going through back and forth. So how do you build code with this particular approach? The way you build the code with this approach is you get to decide what you want to do as an action for the happy path. If that stage doesn't have any failure, you can immediately have a next happy path after it. If there is potentially a failure, you will want to ask the question, do I want to handle this now, or do I want to handle this in the end? And you have a way to really choose between them. So the nice thing I really like about this is, as I said, I'm not dealing with the data and the exception together. They are separated on each line. But the disadvantage is deciding where to place this exceptionally. That you have to decide based on the stage. At every stage, you ask the question, A, is there a failure possibility? And if there is, what do you want to do about it? Do you want to deal with it now? Or do you want to bypass a few stages and deal with it later? That's a decision you have to make. Of course, the answer to that question depends on your business logic, right? It depends on what your application is supposed to do. It's not something arbitrary for you to decide. Let's think about this a little bit further now to see how we can handle this with the problem we have at our hand. Now, keep in mind, a completable future is useful only for one pipeline execution, right? One flow. There's not multiple stream of data going through it. Only one flow of data from the top to the bottom. That's what you're dealing with in this particular case. So what I can do here is something along these lines. So let's get rid of some of these functions we don't care about for this example. So what I will do here is to go back to the main function. And in the main function, let's take baby steps on this. So I could say something along the lines of, let's say output, let's say process, let's call it as a IATA, and send, let's say IAH here as a value. So what does process IATA do? So we could say public, let's say static, and in this case, a function is going to return a string, process IATA, and that takes IATA code, and how am I going to use that in here? Well, we could say a completable future, so we can say completable future dot supply, let's say async. So you want to make an asynchronous call to this particular function. So you can go ahead and say sample get name of airport, and you can call that particular function. Well, actually, that's not quite true. So because that's a supplier, so you can say get name of airport and pass the IATA code to it, and that's going to give you a completable future. So once you get the completable future, what do I want to do? I can then say a dot then apply, and I can take the name of the airport and convert to uppercase. That's what I wanted to do, right? So I can convert to uppercase like so. So then apply. The next step after this is I can say dot then accept, and in this case I can simply say system dot, let's say system dot out, and I can print it right there. We could say print line and we can print it. So obviously in this case, I'll make it a void method like so, and we'll simply call that for the process IATA, and I have it printed in the very end. So, but obviously, you know the problem already, right? Supply async is going to take a supplier. Well, supplier cannot deal with check the exceptions. So that code is going to give us trouble saying, I don't deal with IO exceptions. What do we do? So we are back to square one on this one. You might want to structure your code so you deal with really unchecked exceptions, if you will. So you could say, for example, in here, I have this function, but I do want to handle the exception if that were to happen. But we are not in a multi element pipeline right now. We are dealing with only one element in this pipeline, and we have a different way of handling with the exception as well. So there's a bit of a relief in this case compared to the stream API. So what you could potentially do here is the following. You could say catch exception, and in this case you could say simply bubble it up, and you could say throw new, let's say in this case a runtime exception, and bubble it all to the top. So this is simply saying I want to run through this particular exception and handle it like so. So let's see what it's going to do. So let's make sure that I've got this straight. So this is going to be the try block that I have inside of this, which is going to supposed to end right here. So we'll bring that in. And of course, this is going to be the try for the outside try block that I'm interested in handling, and the catch for that, and return the exception as a value eventually. So that's basically our function we're going to call. Of course, in this case, I'm going to just give it a little delay for it to wait. So we'll say thread.sleep and 1 second. Because it's asynchronous, I want to give it some time for it to finish. And there are other ways you can wait on the response, but this is good enough for our discussion right now. So when I run this code, what do you expect this to actually do? So you want this to go and fire off a request, and you can see the airport code in all uppercase coming back. But what if something were to go wrong? What do we do about it? So back in here, if I said, for example, TAS, which is not a valid airport code, what's going to happen? Just for us to know this actually is calling it, we'll say get name of airport, let's say called, we'll say get name of airport called for, and let's simply say IATA, so we can see that being executed. So when I run the code, you can see get name of airport called for TAS. But you did not handle the exception, so it never reported anything. So what gives? What do we do now? Well, clearly you have an exception that's being thrown towards you. A couple of things you can do. You could pretty much say in here, well, not over there, because you don't want the exception to be transformed to uppercase. You can say exceptionally, and you can take the throwable that's given to you, and what can you do? You have an exception given to you. You could simply say throwable that is given dot get message, right? So you could get the message out of the throwable when that were to fail, and you could return it. So in this case, it says get name of airport called, and it gives you that value, but the exceptionally should have transformed the data. Maybe the network is really slow. It's taking a little longer to run. Let me just give it a little bit more delay here to see it. So when we run it, notice the exception is invalid airport code TAS. That's what it tells us right there. But that's coming from the message right here. That's what you're receiving, right? So you could then say, I could potentially extract the message from that exception and maybe print it out much more. So you can say invalid airport code. That's the exception you're receiving in the exceptionally block, and you can handle that. You're transforming that to a string, and then you can pass it on for printing purposes in here. So that's potentially what you could do. So this gives you an idea how you can transform this. Now, obviously, if I move this up here, what's going to happen? Well, if I move it up there, that's going to be giving everything in uppercase. So you need to ask the question, where do you place this, right? Do you want the invalid airport code TAS in uppercase? Then you would want to put this here. But you're saying, no. I want to just wait until I get to this stage. If the data arrives from here, I want to print it. If there was an exception anywhere before, I want to handle the exception and print the message. So you get to structure your handling based on where you want to, so to say, merge this path and move forward, right? So this exceptionally is converting from an exception to a happy path. So you're going back to the happy path, and so the then accept will run in no matter what in this particular case. So essentially what's going to happen here is, if this was successful, you run this, and that's a pure function, nothing to fail really in that case. So it'll bypass exceptionally, and you will get to this. If this were to fail, you will skip the then apply, come to the exceptionally, extract the exception from there, and this will print it. So that's the way we are structuring this in terms of how we are going to handle it. Again, I won't say this is awesome or perfect. It's a notch better than what we saw in the functional pipeline in terms of how this is being handled in this transformation path. Now, obviously, the question is, what if I have a collection of data that I want to deal with? How do I provide that particular feature in here? Well, you could try something along these lines, right? So you could say, for example, I'm going to just increase this a little bit more so we can see the result. So I'm going to say, in this case, a list of, let's say, in this case, IATA codes is equal to, and let's say, in this case, I want to call this as a list of, let's provide some code here. So we got a bunch of them. And then, of course, let's say I will introduce also incorrect value, so TAS, and of course SAT, and now I could do something like this. I can say IATA codes, and remember, my function is not going to throw an exception at me, right? So stream, I could call upon a stream, and then in this particular case, I could say a map, and we could take the IATA code, and we could instead call the process IATA code. So we could say, for example, sample, and we could call the process IATA code. And this could be potentially, because it's a terminal operation, you could run it at the very end of this as a data, or you can ask this to return a piece of data through the transformation, and as a result, you could just work with this as a completable future itself. So this could be, here's the beauty of completable futures, is they never seem to die, right? Always get back a completable future from this. So you could say, here's a completable future of void, because I'm not really returning any useful data. I could return a completable future of the void from the end over here. So then you can go back and do a map on this one, and that's going to transform from this to a collection of completable futures, if you will, and you can get that back. And then you can then say in here, well, what else do you want to do? You can say for each, and you can process this, or you can do a collect on it as well into a completable future collection, and then you can wait for all of them to finish potentially as well, and then call it done at that time. So for example, let's say if I were to map this over, you could do a to list on this. So that's going to give you a list of completable futures. So we could say this is tasks that you are executing. So you could say, I want to run off these tasks in this by launching a map on it and get the list. And potentially you can block on it and wait on it to complete it as well. So you can write a few more lines of code to say, I want to wait on those and display it, but it's going to go through the pipeline and start executing the stream values one at a time. So as a result, in this particular case, I'm going to remove this message right here. We don't need that anymore. So you can see in this particular case, the airport names being displayed. And like I said earlier, you don't want the thread.sleep. That's kind of wild, but we can get away from that very easily in a minute. So notice now, it is telling us Austin and Bush, and you have a San Antonio and a Dallas Fort Worth, but the ordering is not the same. That's because they are pretty much is executing asynchronously, so they could be running in any order. That's the whole point about asynchronous computations. And if you really care about the order, you'll have to implement a little bit more logic behind it. But this is mixing the streams with the completable future to get the work done. So this is a little bit of a better handling, like I mentioned, Not a perfect solution by any stretch of imagination, but definitely you don't have that issue of having the every a function in the pipeline having to deal with the data and error back and forth. A little bit better separation. So I'll put a little note here, a bit of a bit better with a good separation of concern for each function. So essentially then focuses on data, exceptionally we can say focuses on error, of course, but we still have to deal with a mixture of data handling, handling and error handling, handling in different stages of the pipeline. So not the cleanest solution, but definitely a notch better than what we saw with the functional style approach. I still won't say that I'll give a clean ticket to say this is great, we want to go this route. I would say maybe it's still worth considering going back to doing imperative style. If we have a lot of these multiple levels of exception to handle, maybe that becomes a win even there. So this is again handling, let's say handling exception in the pipeline, right, of a completable future. So that's basically what we saw in here. Let's move a little further now. So we saw how this pipeline pattern works, and we talked about what's nice about it and what's unpleasant about it as well. So that's the next solution in completable future. But having said that, one of the trends you are noticing probably is that in JavaScript, we have the promises, and this approach was quite promising a while ago. But most people writing JavaScript code probably have moved away from this approach right now. So what are people doing mostly when they're writing JavaScript? Most likely, they are using, rather than saying, right, a promise dot, then, and you're writing some code, and then a dot then, and writing some code. And in the case of JavaScript, they do a catch to introduce that code like that. That can become really cumbersome. So rather than doing that, what you're doing mostly these days is you are trying to say, for example, constant result is equal to result is equal to await, and you are calling some function f1, and then you are saying constant result2 is equal to await, and you are calling function 2 with the result 1 in this case. But the beauty of this is you can put a try around it and a nice catch around it as well to handle your exceptions. So in this case, it's an imperative style code, but a lot of people writing JavaScript code have moved away from using promises to what is called an async and await. And the reason why async and await is a bit more popular is it gives a much better way of handling the exceptions. Again, my point about maybe imperative style code is better when it comes to dealing with exceptions. That's an evidence you see in the JavaScript side that people have kind of shied away from promises. Even though the functions are still returning promises to be asynchronous, we are using more and more async and await for the code, and that's a trend we are moving towards. Now, you may ask the question, if that's a trend we are moving towards in JavaScript, what do you expect to see in the case of Java maybe in a few years from now? Well, that change is already happening, as you know, in the case of Java. So you could say in Java 8, what you're dealing with right now is, of course, for example, the completable future, and you say dot then, apply, for example. And then you're dealing with exceptionally, and you're dealing with whatever you want to deal with, and then you're writing code like this. Again, that's a lot like the JavaScript way of dealing with the promises, isn't it? But again, if you think about it, in Java 19, we are going to go back to a different way of programming, which is you're going to say a try and result1 is equal to, and you're going to call the function here f1, and you're going to say a catch over here, exception, and you're going to be able to handle that exception here, and potentially you could go back and say, here is a result 1, and you may try again if it makes sense, and you could do F2 and result 2, maybe a result 1, which could store a value in a result 2, for example, and so on, and you may provide a catch block. So this is, of course, excuse me, this is, of course, as you may recognize, imperative style of programming, and you say, well, how is this any different from what we did? Well, the difference is, thanks to Project Loom, you can have these functions potentially being executed asynchronously. So you can be in a completely different thread of operation, and when you call the function F1, it can become non-blocking. And then when the function completes its work, then the exception can happen if there is one, or you can move on to the next stage. So this brings back life to exceptional handling in imperative style a lot better. So I'm going to say the trend I'm going to see is those of us who have been writing more and more functional style code probably are going to switch over to writing a bit more imperative style code moving forward when it comes to using exceptions. And that is because we can make use of threading more effectively, and we can do more asynchronous programming a lot more effectively. So if you are doing more, somebody was asking me the other day, is Project Loom going to put an end to reactive programming? My gut feeling is Project Loom is going to put an end to Completable Future, because as much as I like Completable Future, still it's a bit of a mess dealing with exceptions, and I can much easily do asynchronous code using Project Loom compared to Completable Future. So my prediction is that Project Loom within 5 years is most likely going to kill Completable Future, because this is a much easier way to write the asynchronous code than trying to write code with Completable Future. So that is what I think is going to happen in terms of how we structure the code and how we program with it. So with that said, let's switch over to one other model, which is the Reactive Stream API. So how is the Reactive Stream API different from the both of the Completable Future and the Stream API? Well, clearly one distinction is when it comes to Stream, it's a 0, 1, or more pieces of data. When it comes to Completable Future, on the other hand, we talked about how Completable Future is really dealing with a 0 or 1 piece of data. Well, in the case of a reactive stream, you can say it is again a 0, 1, or more pieces of data. So this is basically the difference between all of this. So you're going to deal with a 0 or 1 when it comes to Completable Future, whereas a stream is a 0, 1, or more in general in terms of the data that you're going to be dealing with. So that's the difference between these three different types of APIs. So a Reactive Stream API is a lot similar to the Java Stream API in that regard, that it can deal with a stream of data. However, there's one clear distinction between these two. So when it comes to a stream versus a reactive stream, you can say there are some similarities. The first is this is a pipeline of functions, and so is the Reactive Stream API is a pipeline of functions as well. Secondly, this is going to have a lazy evaluation, and the good news is this is a lazy evaluation as well. So you got the similarities to both of those. You saw me show this in the beginning where they both were pipelines, they both were lazy in evaluation. The similarity, though, ends right there. So the question is, how do we handle exceptions? So essentially, the answer to that question in streams is, good luck. So this is not easy. We saw this already, right? So it's not easy. It's messy. It can become complicated. The code is not cohesive. Not really a great idea. And again, I'm a big fan of functional programming, don't get me wrong, but the time I quit really going that route, is when I have to deal with a lot of exception, I scale back to imperative most of the time because my code is a pile of mess at that point. So that's why I say it's a good luck. I'm not really interested in functional programming at that point when I have to deal with exceptions a lot. But on the other hand, the reactive programming has some really beautiful ideas in here. Treat error as data. That's the first thing. The second thing is, in the Reactive Stream API, unlike the Stream API, there is one channel of data. That's what you're dealing with in the case of a Stream API. You're dealing with one channel of data. Whereas in the Reactive Stream API, this is quite different. We have 3 channels of communication. So the 3 channels of communication are, the first is you have what's called the data channel. The second is you have what is called an error channel. And the third one is you have what is called a complete channel. So you have these 3 channels of communication. So it's a much cleaner API in that regard in terms of having these 3 different channels to communicate the data in a Reactive Stream API. So what's happening in the Reactive Stream API? So data flows through the data channel. So that's obvious, right? That's what the data channel is for. Data flows through data channel. At some point, if no more data, a signal may flow, you can say through in this case, the complete channel. And of course, in this case, and the data channel is closed. So essentially, you will not get any more data through the data channel. Once the complete channel is closed, you're not going to get any more data through it done. However, this is also true if there is an error, then first of all, an error flows through the error channel and the data channel. At this point, channel is closed. So no more data will ever come through this at this particular point anymore in the pipeline processing. So essentially the data channel is closed at this time, and you will not get any more data through the data channel in this particular case. So that's a behavior of the Reactive Stream API, which is very distinctive from the way a Stream API works, as you can see. So this is a much more better level of abstraction on top of it. It's intended to provide it. Again, I want to emphasize, not a perfect solution, right? None of the solutions here is going to be perfect, unfortunately. Like I said earlier in the talk, we don't have a clue how to deal with this yet. We are still struggling. So I'm not here to tell you, this is great, go home and do this. Well, treat everything with a bit of a suspicion, but this one is a better abstraction compared to the other things, not the best one yet. So essentially you have a stream of data, and the data flows through the data channel. If something were to go wrong, you're going to get an error through the error channel, and the data channel closes up. The disadvantage in this case is, once the data channel closes, no more processing of data is possible. So that is the consequence of this particular model. So as long as things are flowing and things are happy, you're having a great time. But the minute you hit a problem, that's it, you're stopping the show, you're not going to get any more data flowing through it. So good news, you're handling exception really well. Good news, the code is cohesive. Good news, you're dealing with the error at the end of the pipeline. The bad news is, if something were to go wrong, you're not going to continue to process the next piece of data in this particular model. You're going to just stop right there and not propagate it anymore. You could argue, hey, why not create a reactive stream where you only propagate one piece of data and then wrap that with maybe a stream on the top of it. That might be an overkill, but it might give you a bit of a relief from that, in that you can have this one pipeline. If it were to fail, well, that's a failure you report, but another pipeline for the next piece of data. In that case, you're using the Reactive Stream API more like a completable future to process this data. that may be worth looking at to see if it gives you some relief, especially if you're able to take this all the way down and handle it. And obviously, in this case, the error may happen in any stage in the pipeline, and you're going to go to the end of the pipeline to handle it. So let's take a look at how this is going to manifest itself in the code right here, just to get a feel for it and see how we can use this. So here is the let's go ahead and take the function that we have, the get name of airport. So what am I going to do here? Well, we're not going to use the completable future right now. So we have this list of data right there. And once again, I'm going to simply get rid of this TAS and keep those good airport codes for a second. So what am I going to do here? I'm going to first of all bring in, let's say, import, let's say, IO reactive x dot star. And we'll say, I want to start with the Reactive Stream API. So let's go ahead and say a flowable. Let's start with the baby steps here. So flowable dot, and we will say, in this particular case, from iterable, and we will say IATA codes right there to start with. Then you say dot subscribe, and here comes the output. So system dot out, and we will say print line, and we will just print it out for a second. We'll take baby steps towards this. So I want to just print that particular data out. So you have those three. Well, guess what? This is basically your data channel that you have right there. So your data channel is going to give you the data that we talked about. Then you say there's an error, and I want to really print out maybe that error, right? If that's all you want to do, you can print it out, or you can say error, and then you can print out the error like so. That to you is the error channel that you have. So you're saying, if something were to go wrong, I want to handle that error and print it out. That's what I want to do. And then the last thing, of course, in here is the complete channel. So you can simply say something along the lines of maybe a done to say you are done processing. So when you run the code, you can see the done in the bottom. That's because a complete signal was received. So you have the airport codes and a done in the very end. So the complete channel was activated as well. However, going back to this code, I want to say dot map, and I could take the code and take the data and turn it to uppercase. So I could say to uppercase like so, and convert to an uppercase and send it. Obviously, it was already in uppercase, not a whole lot to really do, but that's a pipeline we are seeing again. But then I can say a dot map. Oh, here comes a charm, by the way. No, go back to this, and I'm going to remove the try. I almost forgot to mention that. So I'm going to remove the try from here entirely. And this can throw a runtime exception internally, but it's going to actually be the code we saw earlier that we are going to use with the try as in there. And I will get rid of the catch block and the wrapping we did earlier. So this is going to be the get name of airport that you saw. And obviously, that better throw IO exception, right? So throws IO exception right there. So the function now is not just wrapping things into a runtime exception. But I go back here and say map, and I'm going to take the IATA code and then call this function, as you can see right here. I'm going to say get name of airport and pass the IATA code to it. Now, the first and interesting good news here is that you can actually call the function directly in here. So it says cannot convert to string. It's complaining to me. Let's see where. Oh, sorry. Thank you. Thank you very much. So essentially, when I run the code, notice there was no compilation error, right? That's the first observation. So what's the good news? Unlike the Stream API, your transformation functions can deal with checked exceptions. This is a departure from what you saw in the Stream API. So if you're blowing up with checked exceptions, you don't have to wrap them into unchecked exceptions. Bring it on, and you're able to deal with it just fine. That's one clear distinction in the pipeline. You didn't have to really hide away from the checked exceptions. As you can see in full glory, you have throws IO exception, and this code is like, no problem, bring it on. I'm not going to give you an error. And the reason for that is the functions you pass to the map in the functional API support exceptions. So you could blow up in them if you really want to. When you run the code this time, what are we seeing as an output? You see the airport in uppercase. You have Austin, George Bush, Dallas, and San Antonio. So far, so good, isn't it? However, what if something were to go wrong? So if you were to go back here and say, here comes a TAS, which is an invalid airport code, and you run the code this time, what does it do? Notice it gives you the right result for the ones that worked. When it runs into an error, it says error, the uppercase error, because that's what I printed in the terminal, and it says runtime exception, invalid airport code TAS, and it gives you that error. But notice what it didn't do. It did not process SAT. That's because a reactive stream API will stop the minute it runs to an error. It doesn't continue with your pipeline. I mean, you could get creative, like I said, to really use this for one pipeline, but maybe that's an overkill to use it for the wrong purpose, right? So, but that's the nature of the reactive stream API, is that it's going to be streaming data until nothing goes wrong. If something goes wrong, the data channel closes, the error channel gets the error, the complete signal is not received. So you can see when you run the code, you don't have the done in the bottom. That's because it didn't finish favorably, right? So as a result, it simply says, sorry, it was an abnormal termination. I'm not going to give you done. On the other hand, as you can see in here, if there is no exception, then that's great, and you're not dealing with exceptions in each of the stage. So by far, I would say this is the cleanest I can come close to keeping the exception separate from the data that you're handling. But again, it's not perfect, like I said, because it doesn't continue with the pipeline once there's a termination, even though it gives you a better handle in handling the exceptions itself. So that's an example of how you're able to handle that in the reactive stream API. So let's go ahead and save this away. Exceptions in reactive streams. Oh, I want to save the notes I wrote here as well before I save that away. So let's take a look at this really quickly before we go to that as well. So I'm going to just grab this notes and copy that over here. So that's there at the bottom of this. If you download and you want to take a look at it, at least you have. So I want to make one more observation here while we are here. So map, filter, etc. Can't call lambdas that have checked the exception, right? So on the other hand, here the map filter, etc. Can have lambdas that may throw exception, right? Throw checked exception. So that's another difference in this case. So we will save that away. So that's basically a difference between those, and I'm going to go ahead and push that in there and save it. So let's summarize what we talked about so far, and where we want to maybe consider this. And the pros and cons of what we talked about. Again, I'll push this into this soon after the talk. So if you want to download and play with the examples, you'll be able to do so as well. Now, the moral of the story really is that unfortunately, though, exception handling is predominantly an imperative style of programming idea. So when we deal with exceptions, by nature, we've been writing more exceptional code in mainstream languages. And exceptions generally blow up the call stack, and then they propagate to the functions you called from until you hit to a catch block. While that model works really well for imperative style of programming, that doesn't go well with functional style at all. The model I want you to visualize is a freeway in which you're driving a car. If you have a problem, what do? Well, you definitely want to exit safely. You don't want to ever go in reverse. So there's no luxury of rolling back your call stack in a functional style. It's a pipeline you have to deal with. That's absolutely essential. So it's worth really asking the question, what's going to happen as we move forward in the future? I would say the pendulum is swinging, if you will. And the pendulum was all the way to the one side where we did imperative style almost exclusively in mainstream languages. The pendulum started swinging this way, and we've been exploring more and more of functional style of programming. Now, how far do you think the pendulum will go? I would say, to me at least, that limit is until we hit exceptions. And so there's a sweet spot, I think, in between where I'm happy to leave out imperative style and program in functional style. But to me, I don't want to go overboard with it and say that's the only way to write code or the best way to write code, because like everything else is, there is limits to what we can do. And I think the functional pipeline, that pendulum is swinging far enough, but the minute we hit the areas of exception handling, we want to kind of slow down and question what we do and say, is this still the right way to do? But to me, the best thing is the power to the programmers, the power to you and me. And that is, we get to use the tool that makes the most sense for what we do. We don't have to convince ourselves that it has to be one way or the other. There are times I would do one way, there are times I would do the other way, and I'm willing to change and evaluate it, but I want to pick the best I know for a given situation. And for me, imperative style is not great when the code is very complex and has mutability. It can become really hard. But if I'm able to write that code in a functional style, I'm reducing the accidental complexity. My code is easy to understand. Code is easy to maintain, easy to parallelize. But unfortunately, that limit is exceptions. And when I hit the exceptions, and then I ask the question, what kind of API am I working with? If I'm working with the Streams API, I generally try to shy away from exceptions in Streams API. I would much rather scale back and start programming in imperative style at that point, because my benefits of functional style are not really there anymore to the extent it was before I get into exceptions. If I'm dealing with a completable future, it's a notch better, but I'm still not convinced about it. But I'm almost certain, like I said, completable future would probably die away in about 5 years. That's my prediction, right? I don't have any wishes for it to go away, but given that you have completable future and you have Project Loom, I think Loom is going to give us a better way to do asynchronous programming compared to a completable future. So I think with the mess of having to deal with the exceptions in it, I think we'll find a better relief in imperative style. And of course, with the reactive programming, I think that's probably the best of the three, in my opinion, though not the best in general. And it gives a nice separation, but still has the flaw that it cannot continue the pipeline when it's blown up. And that's one of the disadvantages of that. But I think moving forward, we have a situation where those of us who got really excited about functional style of programming, in all honesty, I think we will pause a little bit and say, maybe imperative is not as bad as it is in situations where we have to deal with a lot of impurity and exceptions, and maybe it's a balance we want to strike, and maybe a certain situation where we may choose imperative more than functional, and certain situation where we may choose functional more than imperative. I think having that option to balance is a power to us as programmers. I think we would leverage that to get the big win out of it. So hope that was useful. That's all I have. Thank you.